Welcome to today's Explainer. We're diving straight into the ultimate cosmic detective story to uncover the invisible architect of our universe. Imagine looking at a distant galaxy through the world's most powerful telescope. You see billions of stars, right? Just shining beautifully against the blackness. But here's the kicker. According to physicists, almost all of that galaxy is actually completely invisible to us. Today, we're going to break down this massive mystery, unraveling the hard evidence, the leading theories, and what it all actually means for the cosmos. Let's get right into it. Let's start with a massive plot twist. Literally everything you have ever seen, touched, or known, the stars, the planets, the air you're breathing right now, the mountains, the animals, even your own body, all of it makes up a measly 5% of the entire universe. We call this ordinary matter, or baryonic matter, and it's what all our atoms are made of. I mean, it is just wild to think about, right? Everything humanity has ever observed throughout all of history is just a tiny, tiny sliver of actual reality. So the staggering truth really lies in that missing 95%. You've got dark energy making up roughly 68% of the cosmos, and dark matter claiming about 27%. Think about that for a second. When you isolate just the matter in the universe, this dark, invisible stuff outnumbers everything we can actually see by a ratio of 5 to 1. To put that in perspective, about 85% of all the matter in the universe is just dark. So, what exactly is this invisible substance surrounding us? It's literally everywhere, holding galaxies together, yet remains one of the single greatest unsolved mysteries in modern science. The main reason no one has ever caught a glimpse of it is that it's entirely uncooperative with electromagnetism. And I mean entirely. Dark matter doesn't reflect light, it doesn't emit it, it absorbs absolutely nothing, and it produces zero radiation. So our most advanced billion-dollar telescopes, they are essentially totally blind to it. Well, if we can't see it, how do we know it's there? The crucial point here is that we only know it exists because of gravity. Dark matter has mass, and as we all know from basic physics, anything with mass creates a gravitational pull. So we detect this stuff indirectly by observing exactly how its invisible mass pulls on the stars and the galaxies that we can actually see. Let's trace how this whole cosmic investigation started. Back in the 1930s, a Swiss astronomer named Fritz Zwicky noticed something incredibly strange. He was looking at galaxy clusters and realized they were moving way, way faster than they should have been. According to Newton's laws, these galaxies should have just flown apart and escaped into deep space. But they didn't. Something invisible was holding them tightly together. Zwicky coined the term missing mass. But it wasn't until the 1970s that we got astronomer Vera Rubin's truly shocking discoveries. Rubin basically uncovered an impossible rotation anomaly. She was measuring how stars moved around galaxies, and scientists fully expected that stars farther out from the center would move slower. Just like planets farther from our sun move slower. But they weren't. She discovered what we call a flat rotation curve. This means stars at the very edges of the galaxy were moving almost as fast as those right near the center. That was physically impossible, unless a massive amount of invisible matter was wrapped around every single galaxy. So instead of just flying apart like a broken merry-go-round, galaxies are held together by this vast, invisible gravitational skeleton. It's essentially cosmic scaffolding. Dark matter provides the necessary grip to keep these rapidly spinning galaxy clusters completely intact. Honestly, without it, the clusters wouldn't stay together at all, and countless stars would just get flung out into the void. To put this into a slightly more personal perspective, scientists believe this stuff forms enormous invisible halos around galaxies. And yeah, our own Milky Way is sitting right inside one of these halos as we speak. Because of this, literally billions of these invisible dark matter particles could be passing completely unnoticed through your body every single second. But you'd never even feel a thing. Okay, so we know what it does. But what actually is it? Well, let's pull up the scientific suspect lineup and take a look at the leading theoretical candidates for what this mysterious substance might actually be. Now, physicists haven't cracked the case quite yet, but the leading suspects range from WIMPs, that's weakly interacting massive particles, which have honestly been the top candidate for decades, to things like axions, which are these extremely lightweight particles, much, much smaller than an electron. Then you've got sterile neutrinos, which are a hypothetical type of neutrino that could neatly tie up a few cosmic mysteries. And finally, the highly controversial primordial black holes. These would be countless tiny black holes that formed literally moments after the Big Bang. Now, even though we can't see the particles themselves, we can absolutely see their massive effects on the universe through a really fascinating phenomenon called gravitational lensing. Basically, when a massive clump of dark matter sits between us and a distant galaxy, its immense gravity actually bends the light that's traveling toward us. This creates these wild, highly distorted images of distant space. It's kind of like looking through a giant cosmic funhouse mirror. Albert Einstein actually predicted this bending of light way back when, and today astronomers use this exact phenomenon to literally map out where the invisible dark matter is hiding. They look out for these visual distortions, and from there they can mathematically calculate exactly where the invisible mass has to be sitting to cause that specific bending of light. It's incredibly clever. And that brings us to one of the most definitive pieces of proof we have, the bullet cluster. This was a massive, epic collision between two entire galaxy clusters. During the crash, the ordinary matter, the gas and the dust, smashed together and slowed right down. But the vast majority of the mass, the invisible dark matter, it just breezed right through the crash site, totally unbothered. The position of this invisible mass matched our dark matter predictions absolutely perfectly. So, to try and catch these elusive particles right here on Earth, scientists are running this intense underground manhunt. They're building these massive laboratories deep, deep beneath the Earth's surface. You might be wondering, why so deep? Well, they have to shield their incredibly sensitive detectors from all the everyday cosmic rays bombarding the surface, just in the hopes of capturing one single dark matter interaction. But here's the reality check. Despite using these incredibly advanced experiments, projects like Lux, Xenon, and Pandex, all housed inside these deep underground bunkers, we still haven't made a confirmed, direct detection. We are searching around the clock, but man, the universe is keeping this secret really well hidden. Now, if you're suddenly wondering whether this invisible force constantly ghosting through the Earth is dangerous, you can rest easy. It doesn't burn, it doesn't explode, and it doesn't collide with our ordinary atoms. It barely interacts with normal matter at all. So for sure, it poses absolutely no known danger to us. Also, I think it's absolutely crucial we clear up a super common cosmic confusion, the difference between dark matter and dark energy. They are not the same thing. While dark matter acts like the universe's anchor, using its gravity to pull structures together, dark energy does the exact opposite. It's actively stretching the very fabric of space apart, expanding the universe faster and faster. Ultimately, what you really need to take away from this explainer is that without dark matter's gravitational pull, the large-scale structure of our entire universe would look completely different. Stars would have seriously struggled to cluster together, early galaxies might never have formed in the first place, and many scientists believe that life as we know it might not even exist at all. It's that important. Solving this cosmic mystery remains one of the holy grails of modern science, mainly because it's going to unlock entirely new physics. Figuring this out is going to give us new particles, a vastly deeper understanding of gravity, a much clearer picture of the Big Bang, and it will probably force us to rewrite our model of the universe from the ground up. It's a real game changer. It really is the ultimate cosmic puzzle. So, if you enjoyed this explainer and you love exploring these massive universal mysteries, please leave a like and subscribe for more. And I want to hear from you. What do you think is actually out there, hiding in the dark? Let us know in the comments below, and I'll see you next time.